Thank you everyone for joining. Good morning, good afternoon, and evening, wherever you are joining from. We are very excited to have you join us for our SWAN and WaterLinks partnered webinar on wastewater digitalization, learning from different regional lessons to plant level impact. My name is Zolboo. I am the Asia Pacific lead at SWAN, Smart Water Networks Forum. I'll be moderating today's session, and we encourage everyone to put their questions in the chat. And we are hearing from three great speakers today across Asia Pacific and Europe. And if you have any questions during their presentation, please put them in the chat. I will ask after each presenter, and then also at the end, when we get if we have some time, we'll be getting a Q&A and some open discussions. So with our webinar today, we are very much privileged to be partnering with our great partner WaterLinks in the series of webinars. So our first webinar was focusing on non-revenue water last September, and this is our second webinar. So very happy to be partnering with the team. WaterLinks is a nonprofit based in the Philippines, working with utilities across APAC, helping improve operational capacities through their core program. So excited to be partnering with our ongoing programs with them. So just to give a bit of a background for today's webinar, we're going to do a quick welcoming and short poll to know who's in the room, and then the presentations, hearing from three presenters today, and then Q&A and open discussion at the end. So just a quick background for those who are unfamiliar with Smart Water Networks Forum. We are a global nonprofit forum that brings together water utilities, solution providers, and industry experts to advance the smart data-driven solutions for drinking water, wastewater, and stormwater utilities as they move across their digital journeys. And SWAN provides resources and the knowledge hub based for the global sector, including standardizations, case studies, reports and frameworks, and also our communities of practice across different areas. Just a couple of things on our engagement and education side. We have a couple of regional events that are coming up that, if you're around, that we would love to invite you to join us. So one of them coming up is on April 8th. We are a lead digital partner with Asia Water this year. So we'll be hosting a half-day workshop focused on smart water for inclusive growth in Kuala Lumpur, Malaysia. So if you're in town, please join us. I think, Ravina, if you could share the link, that'd be great. Please register to our event, and please contact us if you're coming, because we are shaping the agenda right now. And also, we are excited to share that SWAN is coming to Singapore International Water Week this year again. We will be hosting two different workshops. One is focused on South Asia, one is focused on Asia Pacific in Singapore, both on June 15 and June 18. Once we have more information, we'll be posting them on our website, but would be great to see you there. And without further ado, we would like to understand who is in the room using Mentimeter. So if you have your mobile phone, you can use the QR code. If not, you can also use your laptop or computer if it's easier. Ravina, if you could share the Mentimeter link, that would be great. So let me just share the Mentimeter real quick here. Yep, so if you can see my screen here, you can use the link to what country are you joining in from. It was really great to see all across the different regions and countries. I think we have a big representatives from Australia, Philippines, and South Africa. It's great to see South Africa. We have a Cape Town workshop, Shaping Africa's Smart Water, in just less than a week time now. So very excited to see folks from there, in the Philippines, UK, Nepal. Thanks so much. And great to see a global presence and participation here. And our next question before we move on is, what type of organization do you work for? Is it utility, solution provider? Where are you in the water ecosystem? We have I think we have a great representation from different parts of the water ecosystem, solution providers, and also the water utility is a lot, and also engineering firm and regulator. Really great to see the whole ecosystem coming in to join us. Thank you. So without further ado, I would like to invite Mr. Dorai Narayana, our first speaker, former head of the Planning and Engineering Department of Indah Water Consortium and the board member of WaterLinks, to share with us to set the theme for the topic. Thank you.
Thank you. Hope you can hear me. Can you hear me?
Yes.
Yes, okay. So I only have 10 minutes, so I'm going to go quickly into the slides. Thank you, everyone, for this opportunity. So I'm just giving a regional context of this wastewater digitalization, which we have two more speakers who will be speaking about it. And here we find that when the majority of the countries in the developing world, which we are surrounded here in Asia and sub-Saharan Africa and South America and so on, you'll find that the infrastructure reality is not so much of a sewer system with sewage treatment plant and so on, but more of on-site systems. And these on-site systems are also not systematically designed and built, but of all types of systems, some of which may be just a very simple containment, or even sometimes it may be a direct connection to a drain or a canal or some other land area. So that will be the kind of infrastructure reality that you face. Secondly, the governance here in these countries is pretty, lax. There may not be a proper regulator, and they, by law, local authorities would be required to take care of these. But most of the time, when it comes to on-site systems, they sort of leave it to the people concerned, the householders, to take care of it themselves. They do not consider this as a major part of their role as a local authority, and therefore there is a lack of governance in this sector. And thirdly, when you look at the data availability, that's almost non-existent in many cases. And even if it is existent, you will find that it is insufficient or incomplete, and any data that's available cannot be verified to be reliable. So this is the realities which are the starting point that we have to deal with in this region. But we find that international imperatives like the SDG and so on, and also some national policy initiatives have put pressure on these local governments and also state and central governments to initiate some kind of improvements to service delivery because of customer demands and what people expect. And secondly, urbanization and pressures related to that. It's also creating some pressure on the local bodies and governments to expand coverage, improve the type of infrastructure that is made available to people. And thirdly, there is constraints of available funding and available finances, which means efficiency is another thing that they have to strive for. So these are the things that are really pushing the sector to improve. And part of that, of course, is through digitalization. Now, one success story that we can see is this is the company called Indah Water Consortium in Malaysia. They started off around 30 years ago in the late 1990s. And they have made a success story. I used to be part of that company, and also I used to be part of local government in Malaysia. So I know how the situation was in the 80s and early 90s, where there was no data and data was insufficient, and people used to have information in their heads, and that's where they worked from. But from there, they have improved. And today you find that the information that they have is very, very systematically organized. And they do everything based on very systematic use of information, for starting from planning, forecasting capacity, and what kind of infrastructure is needed, to operational maintenance strategies, shifting from reactive and repair kind of strategies to more of preventive and predictive strategies. Customer management, linking customers and providing customers with very good service. And also asset and risk management systems, which identifies where their focus should be. So this has been Indah Water. And you find that they work with FSM as well. FSM is on-site systems where they provide fecal sludge management, and the routing, the vehicle monitoring and efficiencies all are being done through proper data management. They have several thousand sewage treatment plants, which are all decentralized systems all over the country. And these are all being managed remotely, unmanned, and they have early warning systems and electronic security systems, which are all centrally monitored and connected to the contractors so that it can be immediately attended to any need. Yeah, sewer networks have already been digitized, and information concerning the performance of the networks, the flow, the problems that are arising anywhere, levels, and so on, are being translated as heat maps, so that people on the ground, the teams that are attending to them, are able to see where to go and what kind of actions to take to prevent any overflows and backups from happening. Process controls have also been digitalized through SCADA and equipment sensing and so on. And real-time performance is being monitored. And finally, the risks of assets, including the network assets, they are being monitored, and some kind of risk scoring is given so that operational priorities can be set, and maintenance strategies, and also the CapEx, which is very limited, can be focused to the right areas. So this is broadly what they do. And in terms of service request systems, they have integrated the customer request and complaint system to workflows, and also to their operational systems inside the whole operations division. And the workflows and the escalations and the feedback and closing of every request or complaint has all been integrated together. So this has also resulted in shorter turnover times of service delivery. So nowadays, most of the complaints are dealt with within 7 to 8 hours at most, which is one working day, whereas previously this used to take days. This is the overall diagram that is provided by them, where it's all connected, the early warning systems, the operation maintenance responsive systems, the demands, the security systems, the SCADAs, and all linked through the SAP EAM, that's an enterprise asset management system that they have, which is linked to their contractors and also to the supervisors on the ground. Yeah, and reports are generated for the management to see how the performance is going. These are the general systems that are being used. The SAP is the overall management system that they have. They have an asset management information system, which has even a linear asset module, which covers the sewage pipeline systems, and the customer inquiry system, the lab management to see the performance of the treatment plants, compliances, and so on, and the risk management system, and a GIS, which captures the geographical location of all these. And then it creates many dashboards and reports for compliances, energy saving, utilization, sludge generation, and so on, which is also shared with the regulators. So we have a regulator, we have two regulators. One is a service regulator, and the other is the environmental regulator. And all these reports are shared with them real time. Benefits, I think I don't need to say, but you have benefits all around. The customers benefit. The company itself sees that there's much more reliability of their assets and their performance systems. Cost reductions and optimizations are able to be done. People have a better working environment. Regulators have an easier time regulating and monitoring the compliances. Revenues are much better. Environmental compliances are better, and CapEx can be much more accurately apportioned. So how should we go about it? We saw that the starting points are not very promising. We don't have governance. We have very systems which are not systematic. They may have on-site systems which are undersized or oversized, or some of them may not comply to any design standards. So how do we start? We can start with the data that we already have and try to compile those, audit them, and start with that and make a baby step to move towards what immediate low-hanging decisions can be made from that. And then you start implementing the changes. And as you make the changes, you find contractors are working on the ground, your teams are working on the ground, and they should be gathering information to improve the data systems that you already have. So this way, a cycle of improvements can be done while you are carrying out the work itself. This is how Indah started too. So we had a category of data to say that this is very reliable data, or just we are not so sure that it's reliable. And thirdly, it's something that is just a guesswork picked out of the air. So these were the three categories of data that we had, and we gave a color coding to them. And as we moved along, we find that some data moved up from being unreliable to more reliable. And before we use any data for any purpose, we decide, is the category of that data, is the accuracy and reliability sufficient? If not, then some money will be spent to verify that particular data, because it always costs money to do that, right? So we want to make sure that we do not unnecessarily spend money to collect data which may not really be required. So we prioritize in that way. And this may be one way that utilities in the region may be able to start, and not to depend on systems, because systems without data will not give you much benefit. Yeah. So that's all the time I have. So I'm going to stop here, and maybe there'll be some questions later where we can discuss some of this much more detail. Thank you.
Thank you so much, Dorai, for your presentation and also sharing about your experience at IWK, and also like starting where you are, what's available. I really love the meme you added here. And I think we can see a question from Timothy Dutoit. Maybe Timothy, if you can unmute yourself and you can just ask, do you want to ask a question if you are available? Or I can just read it out. Yep, I think with the interest of time. So Dorai, Timothy asked that with the models you have, oh yeah, he said unable to mute, so that's fine. With the models you have for each node in the network, what sort of event simulation and process optimization technologies do you make use of, if there's any? And what event readiness simulations do you carry out? And do you have automated responses against behavior that aligns with matches to crisis simulations?
Sorry, were you asking a question?
Yeah, if you can, maybe Dorai, if you can see the chat. If you cannot hear me well, can you hear me well?
Okay, all right, yeah. Yes, is the question there?
Yes.
Oh, okay. Is it the one from Timothy?
Yeah, that's right.
Yeah. Yeah. So I think this, if you're talking about the network, we have models to look at network performance from hydraulic performance of networks, and also we are also looking at networks being overloaded not because of hydraulics, but because of blockages, which may be caused by structural defects in the network, or due to roots or some blockages in the networks. So the system actually detects any problems at several levels. It talks about the symptom, that is what is observed, and then after investigation, they look at what caused that symptom, and then there is another level of a root cause. So all these three data that come from the complaint or the problem report to the investigation of the problem is then analyzed to show what type of remedial action that is needed, and then that sort of goes into the system again. And if there is there's a prevalence of certain types of incidents in particular areas. For example, we have cities in parts of the city where people are, there is restaurants which are connected, and we have fats and grease which are discharged from these restaurants and cause clogging of the pipes. So this becomes a hotspot, that this is an area where we need to do constant flushing of these pipes and clearing of accumulated fat and grease. So that kind of strategies can be put in place, and that will be able to reduce the incidents where we need to respond after the event, right? So that's the kind of thing that is being carried out. And sometimes it is a condition assessment using a CCTV, which will be able to assess the structural conditions, and then that can be put into a CapEx plan to reline or replace or enlarge those pipes. That will be a longer term solution. Hope I answered that question.
Thank you, Dorai. Just a quick final question. I think maybe we can move on with this maybe final question. Are you also monitoring data right from water sourcing up to final consumption by the end user? If you can answer that shortly, yeah.
The utility that I'm talking about, Indah Water, is a wastewater utility, and they are monitoring water consumption at the consumer level, because that is what generates the wastewater. So they monitor water consumption from the water supply utilities, and from there they have sewage measurements along the pipelines, as well as what sewage arrives at the sewage treatment plant, and also the effluent that is discharged. So I would say that from the point of generation of the wastewater right up to the point where the wastewater is discharged after treatment at the treatment plant, all those are being monitored, but not water sourcing, because that is not within the scope of this utility.
Thank you so much, Mr. Dorai.
Thank you.
And now I would like to invite our second speaker to the stage, and we are Rahul Chhillar. He is a General Manager of Information Control and Energy at Hunter Water in Australia.
Hi, everyone. I know everybody's in different time zone. I'll be sharing a simple case study where we were able to defer capital upgrade at a plant through digital optimization. The tool we used in this case was Veolia's Hubgrade, but I'll be more around outcomes, because some of the changes, similar changes at other plants, we have implemented directly in PLC as well. I'll first go into a bit of an overview of context of our wastewater treatment infrastructure, and then launch into this case study. For location perspective, we are about 160 kilometers north of Sydney on beautiful eastern seaboard of Australia in the state of New South Wales. And the map on the left also shows our traditional custodians of the land on which we operate. And I'll take this opportunity to pay respect to their elders past, present, and emerging. We service about 600,000 people. Geographically, we are quite spread out. We have got about 10,000 kilometers of water and wastewater pipework over this geographically spread out area. In terms of wastewater portfolio, we have 19 wastewater treatment plants. Almost all of typically use technologies ranging from natural pond-based treatment system to enhanced biological phosphorus removal system, number of just biological nutrient removal plants, biological nitrogen removal plants, which are chemically assisted for phosphorus removal, few membrane bioreactors, and few intermittent processes as well. In terms of sludge systems, we have got aerobic and anaerobic digestion systems. We discharge to ocean, inland waterways, and reuse. Our inland waterways plants typically have more stringent sort of effluent compliance limits. For example, one of the most stringent limits we have is median nitrogen of about 3 milligrams a liter, ammonia of 0.5 milligrams a liter, and phosphorus of 0.25. Whereas ocean discharge plants are relatively more relaxed. And this case study I'm going to talk about today is actually about an ocean discharge plant. In terms of digital enabling, so it's basically our objectives are same. We're trying to enable them more efficiently through digital means. And key focus is to ensure compliance, improve, save energy, save chemicals, and basically optimize plants to utilize assets capacity more effectively to delay capital upgrades. Now, the programs we have in place, we put a lot of solar systems on our plants, and currently we are saving of the order of $1 million per annum through those solar systems we have put on our plants and battery energy storage systems, and that part is expanding. In addition, over the price path, which is remaining years are about 4 years, we would be saving. We have a program to save about 400,000 in energy costs over those 4 years, about 100K a year. And chemical cost reduction through chemical dose optimization through nice feedback controls. We are on track to save about 400K this year. So there's quite a bit of an appetite to use smart systems to save energy and chemicals. And we also looking heavily into the biggest potential gain is by investing into smart systems to defer capital upgrades. And 2 or 3 examples are there, of which one I'm presenting today. The direction in terms of digital we're going in, currently the plants we have, they like most of the plants you guys have, they are all SCADA PLC controlled, all mechanical plants. Operator is there only for 8 hours a day. Otherwise, they operate themselves. DO control and all level control, and that's quite standard. The direction we're going for more deeper insights through enhanced senses. And by that, I means nutrient analyzers, sludge blanket analyzers, basically, and solids analyzers. We're putting quite a few of them to get deeper insights into the process under various operating conditions to give us a deeper understanding, and then coupling them with advanced controls to gain operational optimization gains or utilize assets capacity better. Then I think there is a third dot point which I got there. We're going in that direction. In treatment space, we haven't done as much work. We're going towards like building on our machine learning platform with our data science team here to start quantifying risk on dynamic basis to guide our investments. We have been doing that quite a bit we have started doing on networks, and now we're going to launch that into the treatment space. So that's the digital direction context we are in. Now, getting into this project context, Belmont, which I'm going to talk about today, it's for the wastewater treatment enthusiasts. We've been time constrained. I won't go in detail of the process, but it's like a standard modified Lützek-Ettinger configuration, which is for biological nitrogen removal. This plant does not have nutrient limits, but it was designed to remove as a commitment in our environment impact study to remove ammonia. So we get ammonia less than 1. So it is a biological nitrogen removal plants. So like if for standard modified Lützek-Ettinger process, after screening grit removal, you go to bioreactor, where aerobic zone converts ammonia to nitrate, you recycle back them to your anoxic zone, where in presence of carbon, you denitrify and you separate solids in your clarifier, your clear effluent goes out, you recycle your return activated sludge back into the process, into the reactor. Similarly here, we got screening and grit removal system. We got 5 reactors here, roughly 4 megaliters each. And then and you can clearly mark out there that which one is aerobic and which one in anoxic zone. They go about 75% aerobic, 25% anoxic. Treated effluent from bioreactors flow via a channel into 4 clarifiers. And basically your return activated sludge is pumped back into the process. Clear effluent goes to ocean outfall. And to maintain sludge edge, basically there's a wastewater pump station sitting on this channel that's transferring wasting mixed liquor from this channel to dissolved air flotation system. Then it goes through aerobic digestion system, and for dewatering centrifuge, and then sludge is applied for beneficial reuse application. The problem context is that basically our clarifiers were constrained in terms of serving in wet weather solid flux they were exposed to due to higher flows. So there was a capacity constraint in place. This flow divider that divides flow between 4 clarifiers, it's not a beautiful vertical flow divider, so it's causing unequal division between the clarifiers. And the solution that was proposed was to basically install an additional clarifier and construct a new sort of a flow divider, replace this flow divider with a proper sort of equal dividing flow divider so that we can utilize all clarifiers capacity effectively. So in a conventional solution, all these reactors are operated continuously, and basically the return activated sludge from clarifier was returned at a rate which was proportion of inflow. In this case, it was 80%. So if, for example, if your inflow into the plant is 500 liters a second, you're pumping back 400. So that was the conventional solution. It cost around $20 million. What we have settled on, then we looked at the plant's behavior. Okay, so wet weather capacity constraint. How long are our storm events? Most of those events were like 2 or 3 days, and there was a large sort of a reactor storage volume and clarifier volume. Then we thought, okay, this solid flux issue in wet weather, can we ride that out by storing sludge into reactors and clarifiers during those wet weather events and still remain within solid flux capacity envelope of the secondary clarifiers? So to facilitate, what did we do? We put sludge blanket analyzers into each of the clarifiers, and basically we put nutrient analyzers. So we made RAS rate totally in proportion to the sludge blanket height. And during wet weather, we started intermittent aeration into the reactor, so they'd start acting as sludge storage tanks, so that solid flux going into the clarifier is less. And when we start storing sludge into the clarifier, so the solids returned are less, then in that case, solid flux remains within permissible limit. There is a must warn that, like, basically what we're doing is through sensors, we're trying to utilize capacity of existing structures to store sludge. It's not as good as like a physical solution. Like it depends on the finite length of the storm events. If storm event goes more than 3-4 days, I think you start exhausting. Depending on storm event, the ability for it to ride out would reduce. So just be mindful of that. So with this solution in mind, so in a nutshell, the change we implemented through this optimizer, which interacts with PLC and gives the set points to PLC. Before, we were aerating continuously, and RAS was directly in proportion to flow. Now, after, in wet weather, we start buffering solids into the reactor to reduce solid flux onto the clarifier, and RAS rate is according to sludge blanket height, and aeration is aligned to ammonia concentration. What it means is that intermittent aeration capacity, we have also stretched into dry weather to save energy, and that's according to the ammonia concentration there. So in a nutshell, we basically buffering solids into the structures to remain within the solids flux capacity of the clarifiers. So operational outcome, solid flux capacity increased by, we could handle, I think it's not that solid flux capacity of the clarifier has increased by 23%. What it means is during those wet weather events, we were able to store sludge into reactors and clarifiers to ride out events which in conventional way, if we were continuously aerating, would have resulted in 23% additional solid flux on clarifiers. We were able to ride out without any non-compliance issues. We remained compliant in TSS and other parameters, and our wet weather resilience got improved through this system. There were some challenges, and I'll come to that in a second. So these sensors provide really good insight. So this is an event like before this upgrade was implemented. You can see the sludge blanket in clarifier was very low. This y-axis is actually showing the height of the sludge blanket. It was quite low, so it means we were wasting unnecessary energy. We were not utilizing the storage capacity of the clarifiers. And then during the event, you can see actually unequal flow division as well, as each clarifier should get equal flows, but sludge blanket height in each is different. So the flow distribution between clarifiers is a bit biased because of that flow divider. And we haven't solved that problem. So basically you can see the sludge blanket here went above 4 meters. Now this clarifier is at a depth of 4.5 meters. We were lucky there. In other plants, our clarifiers are mostly around 4 meters deep, and we would have lost a lot of solids. So this was the event before clarifier, and this is almost the solid flux capacity of this particular system. This is an event after we implemented this solution. this optimizer. And one clarifier you can see here went offline. So with 3 clarifiers, you can see on the left side during dry weather, we're modulating RAS rate according to sludge blanket height. So we're saving a bit of energy there. But by storing sludge into reactors and clarifiers, we were able to ride out this 2 or 3 days sort of a storm event without causing any TSS compliance or excessive sludge blanket buildup issues. Now, economically, what we did is we have been able to defer next upgrade to about 2050 as per our modeling at the moment, and which is 16% additional growth. So this upgrade would have costed us 20 million, probably more in today's dollars. Energy savings, I think by stretching this optimization, intermittent aeration, and RAS control through sludge blanket, we were able to save about 40%. I must say that this particular optimization has only saved about 15%. And 25% actually has been saved because we increased diffuser density in reactors substantially, and that increased the oxygen transfer efficiency. And this 15%, if I compare, that doesn't cut the operating cost of the optimizer, but the main driver here was capital deferral. And in that case, it has become quite a productive solution. Challenges that we encountered, if I go back some slides, as I said that during intermittent aeration, our sludge wasting is happening from this channel here. So what that happens is when you're intermittently aerating, linear mix is coming in. So we lost that ability to have effective sort of a hydraulic control of the sludges, and we're implementing solutions in that space now. And due to that, at times, mixed liquor concentration went up way above, which kind of start defeating the purpose because your solid flux on clarifier starts increasing. But unequal flow division between clarifiers still persists because this digital solution is not going to solve that. This is mainly about riding the storm events. Once what happened is in dry weather, there was another challenge. We pushed this intermittent aeration bit too far, which resulted in anoxic condition, which slowed down the settling of the sludge. SVI went up, and that then at that time, this optimization for a period didn't work very effectively. Now we are ensuring that an aerobic fraction through intermittent aeration always stays above 40% roughly, to basically not to happen. Key lessons that are learned, like sensors provide deep insights, and if they are controlled through effective controls, we can save energy, and in other plants we have saved chemicals when we are on this path. Optimization does reduce risk, but doesn't eliminate it. It doesn't take you as far as you added a lot of extra capacity, and optimization has boundaries, which needs to be understood when we start implementing the solution. Final messages that I would like to share here is that sensors are great. They provide deep insights. And when we combine them with effective controls to design for the outcomes that your subject matter experts are asking for, and that's quite important, that these need to be led by outcomes, need to be led by subject matter experts, and we digitally enable those solutions, then we can get quite a few good operational efficiency gains as well as capital deferrals. And I think the direction we're going in risk quantification, because all of our investments are risk-based, if we can have dynamic risk quantification, looking at all different weather and growth conditions, then this will help a great deal to start optimizing our investments. I'll stop here and try and answer some questions. Thanks.
Thank you so much, Rahul, for sharing about Belmont, the wastewater treatment plant. I think it's really good to see the challenges and also a lot of economical efficiency that you witnessed. So I know that you would like to propose the audience to think further when we were chatting earlier, that how clearly defined are their optimization boundaries, whether they know their further optimization begin to risk process stability, right? So why would you want them to focus more on this and think further on clearly defining their optimization boundaries?
Look, it's like there is asset, it has certain capacity. You're pulling some levers for certain gains to save either operating costs or capital investments. They always has flow and impact on other things. So you need to be mindful. For example, this plant, we had a lot of leverage in terms of there is no ammonia limit. So intermittent aeration can work. If I'm taking this solution to a plant which is inland and has got a very stringent ammonia limit, for example, less than 0.5 milligrams a liter, I can push that intermittent aeration only so far. Then other thing is like sludge wasting I mentioned, which we got wrong when we were initially designing solution. Now we learned out of it. So when we do optimization, I think we all need to think about, okay, what other impacts are flow-on impacts and be mindful of them so that we have adequate safeguards, what quality outcomes we are after. And that because if more stringent effluent quality will restrict how many levers you have to pull. If you have like ocean discharge plant, we had more levers to pull. I will not replicate this solution exactly in the same form to an inland plant. So that your exact variables you are facing at your facility need to be accounted for. That's what I meant. So I hope I answered your question, Zolboo.
Yeah, thank you so much. Thanks, Rahul. With the interest of time, I think we can move on to our next speaker, and maybe if there's any final timing for any open discussion, maybe we can come back, Rahul. Thank you so much. So I would like to invite our last speaker, Daniel Navarino, head of Castiglione, Sherry and Paceto Wastewater Treatment Plant. I'm not sure if I'm correctly saying it, but from SMAT that we would love to invite you, Daniel, to share.
Hi, hope you see my presentation. I'm Daniel Navarino and I'm from SMAT. SMAT is a society that, an utility that plays a role in northwest of Italy. We manage many plants in terms of water cycle, coming from water supply to wastewater treatment plant. In particular, we manage more than 380 wastewater treatment plants. Our area of intervention is near the city of Torino. Torino is the main city in northwest of Italy. It's an industrial city with an important industrial activity. And during the year, we try to manage not only civil wastewater, but also industrial wastewater in the same sewerage. So our wastewater treatment plant must be able to treat not only civil wastewater treatment plant, but also industrial sewerage. This is an important thing that we have to take into account, also because we release our treated wastewater into River Po. River Po is the main Italian river in northwest of Italy, and Turin is the first Italian city that the River Po meet during his path to the sea. For this reason, there is a particular focus on our activity in terms of wastewater treatment. As you can see, our territory is quite wide. We serve more than 2 million people resident, and our sewer network can be considered more than 10,000 kilometers long. So now I focus my presentation on our digitalization activity. What I will explain to you is something more very, very similar to the activity and to the presentation of Rahul, because our experience can be very, very similar to that presented before me. As you know, wastewater treatment plants are a complex system that need a lot of energy for their processes. Our main goal was related to saving energy consumption. In Italy, in Europe, energy have an important cost in terms of euro per kilowatt hour. So our main purpose was that of optimizing energy consumption. In order to do this, it is necessary to increase processes efficiency. After this possibility, investigate a natural-based solution for wastewater treatment in order to have an important decrease of consumption of chemical, decrease of sludge production. In Europe, sludge are waste is so it's a cost for our utility. And if we are able to decrease the sludge production, as a consequence, we optimize energy consumption. This is the cycle of idea I would like to explain to you in my presentation. Where did we start? As Dorai said, it is important the initial decision. Start where you are using available data. The available data we had were based on energy consumption. We started with the installation of an energy consumption monitoring system localized in our mainly most important wastewater treatment plant, that is Turin wastewater treatment plant, that I manage and that serve more than 2 million people equivalent. Our purpose was that of monitoring the biological processes for nitrogen removal that are the most important in terms of energy consumption. After the installation of the energy consumption, we moved with the installation of a process control based on alternating phases of aeration into biological tanks. The same system presented by Rahul in Australia. This technology can be considered mature in our sector. And in order to be effective, must be preceded by the installation of ammonia and phosphorus analyzers in order to have a better monitoring of the processes. In fact, this technology needs more robust data from field in order to be effective. At the end, we also experienced the possibility of combining different technologies for nitrogen and phosphorus removal with a particular focus on natural-based solution. All these activities are fundamental, but must be taken into account also with a strong modernization of wastewater treatment plant and machinery fleet. What we did in our plant was to perform the passage from a traditional pre-nitrification biological treatment plant, very similar to that one presented by Rahul. This is the scheme. This is of our plant. What we see from our SCADA. It is the plant is made of primary sedimentation, pre-nitrification tanks with the recirculation of mixed liquor, nitrification tanks with continuous aeration, sedimentary secondary sedimentation, and then the wastewater goes to final filtration. The phosphorus removal in this version of our plant was performed only using chemicals for phosphorus removal. In particular, we use ferric chloride. As I said to you, we wanted to pass from this low digitalized system into a highly digitalized system based on alternate aeration of the process. In this, this is the actual configuration of our plant. We completely remove the mixed liquor recirculation. We perform, now we are performing alternate aeration into biological tanks. for nitrogen removal. And all the volume that was occupied for pre-identification now, without the with the exclusion of the recirculation of the mixed liquor, can be considered as an anaerobic volume in which we perform phosphorus removal in a biological condition. This system obviously is more digitalized and need a specific and strong control of the process. The first thing that we did, as I said to you, was to change our machinery fleet. We started from the changing in turbo compressors. It was this was the main activity to do, because we needed to have more efficient machines in order to provide air to our biological treatment plant. We also performed a complete replacement of the control and command panel for turbo compressors and the replacement of the flow control valves for each tank. After this activity that we can consider a predisposition for future digitalization of the process, we approached the intermittent aeration for nitrogen removal. Our plant is more particular because it's made of 4 different lines. Each line can be considered a wastewater treatment plant with its characteristics. Each line has 6 tanks for alternate aeration. The turbochargers are fed with medium voltage energy. So we decided, in order to preserve the machinery, not to switch off the turbochargers in order not to have a problem with our electrical compound. So we approached with our colleague from ATC in this society, engineering society northeast of Italy, a specific system for alternate aeration. The main purpose was to improve the removal of nitrogen, achieve a 78% of reduction of nitrogen for regional targets, and have energy saving. The solution can be considered completely customized on our necessity. This is how appear our SCADA if we investigate and monitor the system. This is an example of the effectiveness of alternate aeration. As you can see, in the same tank, nitrification and denitrification occurs in time, monitoring ammonia. The same thing that was explained by Rahul in the previous presentation. So we monitor ammonia. When the ammonia goes up, we increase the aeration. And as a consequence, oxygen increases in the tank. When the system decides that the ammonia is reached the target, the low target, the aeration stops and the denitrification occurs in the same tank. The system is controlled by a process controller. The process controller speaks continuously with the PLC that is on site. The PLC receives the signal from the field. The signal from fields are of various kind. We monitor oxygen, airflow, valve position, air pressure, ammonia. All these data are collected to the PLC, sent to the control panel. The controller analyzes the data coming from the field and gives back his idea of monitoring the system. giving information to the system for increasing or decreasing air and so on. Other activities that we are performing is the completely revamping of the aeration system, including also a monitoring system for analyzing the efficiency of air distribution inside each tank. As a consequence of the improvement of digitalization, we also perform phosphorus removal in a biological condition, because the technology permits to use less volume for biological processes. Part of the volume, that one which was used for pre-denitrification, and now is converted into anaerobic volume for the growth of bacteria and the removal of phosphorus. Another technology that we are using in the plant in order to achieve better nitrogen removal is the use of Anamox bacteria for the removal of ammonia in the stream coming from a centrifuge. Also, this system is very delicate in terms of process control, and need a specific controller in order to analyze the ammonia inside the system and the transformation from ammonia to nitrite in order to remove nitrogen from the system. Wow, I don't have so much time, so I want to go fast to the end of my presentation. This is a simple graph that relates energy consumption and the nitrogen removal in our plant during the year. The data comes from 2011 to 2025 and are organized by 3 years of data. As you can see, we can divide the graph into pre-digitalization phase and into a post-digitalization phase. Before pre-digitalization, we only worked on machine. So we achieved a reduction of energy consumption from 65 million kilowatt hour per year to more or less 55, 58 million kilowatt hour per year, only working on machine. From 20 and 22 on, we focused our attention on digitalization. In this, as you can observe, if you look at the orange line, we increased the nitrogen removal, going up to 83% of nitrogen removal in our stream, but in the first 3 years, from 2020 to 2022. But at the present time, we are trying to focus our attention with the values of nitrogen removal a little bit higher than the target, that is 78%, in order to achieve more important energy saving. As you can see, it is very important, the process control analysis. As a conclusion, some of my conclusions are very similar to that one of Rahul. It is very important when you decide to apply digitalization, the cost-benefit ratio of the system. It is important to improve digitalization in a wastewater treatment plant with the revamping of machine. And you have also to keep into account that it is important to have a deep knowledge of biological processes. And to do this, it is necessary to create new professional figures in wastewater treatment plants, such as process managers, PLC managers, expert in process instruments, and probes maintenance. For the future, in Europe, we have an important challenge, which is the new European law concerning wastewater treatment that will lead to new limits for nutrients and energy neutrality for wastewater treatment plant. This is my presentation. I think I have reached the end of my presentation. Thank you very much.
Thank you so much, Daniel, for sharing about SMAT's process and program towards the improving nutrient removal and also reducing energy consumption. Very impressive. And just a quick one for everyone. If you could stay for 5 to 10 minutes to just go over quick questions and our closing remarks, that would be great. But otherwise, I'll be sharing all of this information and slides afterwards. But if you could stay for 5 to 10 minutes, that would be great. Daniel received a question that how many of your wastewater treatment plants are being monitored using similar systems, or is it only for larger treatment plants or even smaller ones?
More or less, all the plant up to from 10,000 people equivalent to the biggest one, which is Turin wastewater treatment plant, are monitored. So all the plants are monitored. Not all the plants have an alternate aeration system for wastewater treatment. I'm in my control room in SMAT. Now I change 1 second my camera. If you, okay, as you can see on the background, there is the system for monitoring all the plant in SMAT. So it's a very complex system that we approach.
I think we just lost your camera now. I think it's just, can't see you.
Have you seen the background?
I'm not sure for everyone, but I cannot see. Oh yeah, I can see you now. That's great. Oh yeah, we can see now. Yeah, full background.
Yeah, in the full background, you see that there is a full screen with all the SCADA coming from SMAT.
Yeah, so I think we have just another question coming through for Daniel and Rahul. Maybe I think with this, we can just quickly move on to our quick open discussion, maybe with my final 1 or 2 questions for both Daniel and Rahul. If you can turn on your camera, and also Dorai and Mai, if you could. Zoya asked that it looks quite promising. Just one question to both. How do you feel working with these digital tools? How are they different from SCADA and PLCs? Maybe Daniel, do you want to give it a go?
Yeah, at the beginning was not so easy because the system is, in our case, really customized on our system. And our plant is more than 40 years old. So it is the challenge was to analyze the system and customize it to a reality that is not so young in terms of wastewater. Then we also did a lot of challenge in order to make formation for our people working on the plant. This is the main challenges of our activity.
Thanks, Daniel. I think it's a good question. I think once you plan for the outcomes you're after in terms of tools, then you need to do a bit of a planning. What's the best tool to get to there? So like the challenges you face is in this particular solution, in my case study, was a optimizer, which is sitting and giving set points to your PLC. So you have to come up challenges of your cybersecurity, getting your digital on board. The data is going on cloud. Treatment people are really scared of putting anything on cloud currently in the modern climate. But I would also like to say you don't have to have external tool. Depending upon your complexity, at some other plants, we are implementing some. If the problem is not as complex, we are implementing some solutions directly into PLC as well. There's an example at Edgeworth where we're doing the same intermittent aeration and all that. We're just coding straight into the PLC. So it depends on your situation and case. how complex it is and what tool to use. But yeah, there will be challenges in terms of getting people on board. There's so many solutions. Which one are you going to adopt? Cybersecurity challenges. There are quite a few you have to jump across.
Yeah, thank you, Rahul and Daniel. Yeah, go ahead, Daniel.
It's also that of having a B plan. Yeah. We have also in all our plans a B plan because something could happen. And our main focus is that of making wastewater treatment. So we must be able to treat wastewater in every case, also if digital system fail for many reasons.
Thank you. I think just a quick final question, if I may, for everyone, just a quick 1 minute would be Rahul, Daniel, Dorai. What would be maybe the key takeaways for utilities and anyone from the water industry who are joining with any like different maturity levels joining in? What would be your key takeaway within like maybe 30 seconds to 1 minute? Maybe we can start with Dorai before I hand it over to Mai. Oh, I think you're on mute, Dorai. We can't hear you.
Yeah, can you hear me?
Yes.
Yeah. So I think what we are hearing from have some feedback here. Yep. So what we were hearing from Rahul and also Daniel is for particular plants, the optimization. But when we look at a city system, then you find that you need to optimize. That was why I was asking Daniel about whether you do that for all plants. And also you find that when you have a city where you have many on-site systems, then it is more of a management of the on-site systems that becomes a priority. And how do you do that efficiently? And how do you do that incrementally? So that becomes a challenge. And many of them, you can see that the questions are, where do we start? We don't know. We don't have a system. Or sometimes when you get vendors who come and give a system, it's overwhelming for the cities because they don't know where to start with it and they don't know how to use it. So I think from the experience of what we went through, I would say that you need to start small and you need your people to really understand what are they trying to do and what do they have. And then slowly build up until they're ready to get into a system mode, which is what we did. We started with simple Excel sheets and, manual measurements were entered into that. That is how we started. And then now, of course, we have gone far ahead. Once the data becomes useful and the people on the ground can actually see the value of that, the data that they are collecting, then you'll find that it just moves ahead by itself. And I think that is the way I would suggest for most of the utilities who are here, I think, who are struggling with that kind of problem before you get to a more matured level. Thank you.
Thank you, Dorai. Maybe Rahul, that's a great answer. Rahul, do you want to go ahead?
Thanks, Dorai. I think that was a great sort of advice. I think one takeaway I would say is that involve your subject matter experts early on, because it's about outcomes. Sometimes people get hung up on tools too much. What tool to use or what outcome you're after. You involve your subject matter experts, clearly define the problem, what the boundaries are, what the opportunities are, and then start thinking about what's the best tool to get there. I think that's what one key insight I would like to share. Thanks.
Thank you, Rahul. Daniel?
Yes, well, only one thing I want to do is that don't forget to that we are all we have to know the system before apply digitalization. Sometimes what I see is that people from the office think that they can control everything and that this is enough. No, this is not enough. We must be curious, and our curiosity can be satisfied only if we go on site. This is fundamental because all the things that we receive from our wastewater are, yes, very important, but what is more important is to be on site, go through the plant by walking, looking at the tank, smelling the plant, because without these things, you can do the process correctly.
Thank you very much. So I just shared one link for our next programming. It's the same link on the Mentimeter. With the interest of time, if you can go there, and if there's any other topics that you would like us to cover in the next webinars, please share that there. But I would like to now invite our partner from WaterLinks, Flor, from Executive Director at WaterLinks, to share hers. I would like to invite Mai to the stage. Thank you.
Thank you, Zolboo. First off, thank you to the speakers, each one very informative and excellently presented. So thank you for that, gentlemen. What is clear is that digitalization has the benefits to digitalization is very, very clear. Of course, lowering operational cost, resulting in more efficient and reliable operations. In the case of Hunter Water, as Rahul said, even to the extent of deferring capital upgrades, which for many utilities is a very good thing, because having to pay for a large infrastructure cost that you can defer would be very helpful to any utility. Of course, digitalization as well results in improved services to customers, which is the main event for us and for you as people in the sector. And as well, it lowers environmental impacts. What we heard today is that we all need to do some introspection, as Rahul had suggested. There is no such thing as a one-size-fits-all, so you need to understand the current situation in your respective utilities. And this, in the case, for instance, of SMAT, Danielle has said very clearly it was to reduce energy consumption. But whatever the objective is, you need to start. And you need to start now. You don't have to go big, as suggested again by Dorai, but you can start very small and from there understand your system better and hopefully get to where these three utilities have now come. So with that, thank you very much for your time, and we hope to see you in the final series of this, final session of this webinar series with SWAN. Thank you.
Thank you, everyone.
Zolboo?
Thank you, Mai. Yeah. Bye, everyone. Thank you to all of our speakers, Danielle, Rahul, Dorai. Thank you to the WaterLinks team. Thanks for everyone who stayed until the end. I'll be following up with you with all this information. So thank you so much. See you later.
Oh,
bye
and
for
by
now.
the way, the presentations are posted on both our websites for those of you who are interested. SWAN's
yes,
and
both
Water.
on WaterLinks website and SWAN Forum website. So we'll be sharing all this information. Thank you all. Bye for now. Please take care.
Bye.
Bye. Bye.